Hey guys, back again with another reaction. This time we're watching Game Theory, why Eevee is the missing link to Pokemon evolution. I don't know how I'm gonna fit that into the title, but you know, that's just the way things are. So here we go. Starting in 3, 2, 1, click.
This episode finally solves the mystery of Pokemon evolution.
I hope it
That's
does.
No cringy opening joke, no nothing. If you want to learn the truth about what's really happening when Pokemon evolve and how it applies to us, well then, this is the video for you. Plain and simple. Roll intro.
The time is finally here. The gates begin to open. The pieces are in place for you. Use everything I taught you to solve my mystery. Your quest begins at theoristgateway.com. A prize awaits you.
Oh, an ARG.
Hurry. Time is ticking.
Hello, Internet. Welcome to
Interesting.
Game Theory, the self-proclaimed Garbodor of the Internet. With the release of Pokemon Let's Go Pikachu and Let's Go Eevee, it seemed like a fitting time to take a look at one of the most adorable Pokemon ever created.
Not
No,
Pikachu.
Not Pikachu. Jeez, that guy gets enough screen time. We're talking about Eevee, who's unique within the Pokemon universe for being the first Pokemon to have branched evolution, i.e. the ability to evolve into one of several Pokemon, starting with 3 options in Generation 1, Jolteon, Flareon, and Vaporeon. And since Gen 1, the list of possible evolutions has just gotten ridiculous. You can now evolve into 8 possible Pokemon, ranging from alien cute to kawaii cute to eco-friendly cute. Since then, there have been other Pokemon who've gotten access to branched evolution, but to this day, Eevee is still the king. And so I started to research Eevee's unique evolutionary abilities, and then pieces started to fit together.
That's the reason everybody
More
goes with
pieces,
Eevee, right?
more,
Like,
until finally the entire mystery
you can
of
have pretty much
Pokemon
any type you want with
evolution
it.
lay solved before my eyes. That's right, Eevee is the key that solves what Pokemon evolution actually is. For years, we've made jokes of, that's not how evolution works, and clearly it's not. But we've never been able to put a label on what is really going on. At least, until today. Today, we solve the riddle that is Pokemon evolution once and for all, and it all starts with this little guy. According to Eevee's Pokedex entry in Diamond and Pearl, Eevee is a rare Pokemon that adapts to harsh environments by taking on different evolutionary forms. If you squint at this explanation, it kind of seems to line up with the principles of evolution.
Matpat should just be the voice
where over time,
for
living organisms
every
change their
Pokedex
looks,
entry.
traits, and abilities to adapt to their environments through Darwinian survival of the fittest. But the problem is that in Darwin's definition, this is happening over hundreds of generations. What's happening to Eevee is happening instantaneously when I shove a colored rock in its face. What we see happening in Pokemon would be like if I took a turkey to the North Pole, stuck it next to an iceberg, and suddenly it evolved into a penguin. While admittedly that would be really cool, and judging by how desperate Game Freak seems to be for new Pokemon ideas sometimes, it wouldn't really surprise me for a Penki or Turgwin to be in Gen 8. It's just not the way things happen in nature. So evolution alone isn't explaining how
New
Eevee's
Pokemon.
physical
Need a new
changes are
Pokemon.
happening. But believe it or
literally
not,
just an
there
ice cream
is,
cone.
in
Yep.
fact, a
Yep.
scientific
Next one.
explanation
Next
for
one.
Eevee, which is good because I like Eevee and we already
some
referenced
keys.
many nice video game
Yeah,
characters
keys.
on this show. It's called epigenetics. Epigenetics is
Literal
something that
garbage?
you don't
Yeah, that
usually
works.
get into unless you're majoring in this stuff in college. So all you younger viewers, get ready to blow your teachers' minds when you drop this knowledge bomb in the middle of your lesson about Punnett squares. Those are so like 4 years ago on this show. So what is epigenetics? At its core, it's essentially the phenomenon by which animals are born with one set of genes, but potentially have parts of their DNA that are locked at birth and can later be unlocked by certain things happening in the environment. If that sounds weird, think of it this way. You have a ton of DNA in your body, 2.9 billion base pairs.
I've
but
never
not
heard of
all
that.
that DNA is working all at the same time. Without getting into the nitty-gritty of genetics, your cells have specialized proteins that turn off and on different genes throughout the course of your lifetime. When you're a kid, you have a ton of genes turned on to do things like grow your bones, build your brain cells, and create the hormones that make you fall in love with literally every creature that you pass in the school hallway. Later in your life, though, some of those genes get locked back up. When that happens,
That
your
makes
metabolism
sense.
starts slowing down.
Oh.
You stop producing color for your hair and it turns gray. As you get older, you have all the same genes that you started with on the day you were born, but how you look is depending on which ones are turned on and
Ah.
off. Your epigenetics. Right now, my baby Oliver has
I did not
blonde
know
hair,
that.
but Steph and I have brown hair. So, should I be worried about Steph's relationship with the milkman? Is Steph cheating on me? Of course not. At least I don't think so. Steph! Steph, are you cheating on me? Oh, yeah, sure. That's what you would say. No, what's really going on here is that right now, most of the genes in Oliver's system that produce melanin, which turns your hair brown, are turned off. Like, way off. Just like I had when I was his age. But when he gets older, those genes get activated, and his hair will turn brown just like ours. His physical traits will change as his genes
I've seen
turn
that
on
before.
and off.
Like kids
Now,
who
with
had
animals, what epigenetic
originally blonde
researchers
hair,
discovered is that
it changes
some
into
animals may
like
be born with
brown
lots of
or
genes, but potentially
a
have
darker
parts of
shade
their
later
DNA
on.
that can be unlocked by certain triggers in their environment. A great example of this are honeybees. Yeah, I know. I just dedicated an entire episode to bee talk as it relates to Peachette. Maybe I'm just going through bee movie meme withdrawals. I don't know. Bees are fascinating creatures, and in this case, they are the perfect Eevee example. So, like I covered back in that episode, female bee larvae can grow into either a queen bee or a worker bee.
Oh.
What makes the difference here is the food that they're given at birth. Bees given royal jelly become a queen, while everyone else becomes a worker. So in this case, royal jelly is basically the evolutionary stone for bees, determining what form the larval bee evolves into. It even
Once
changes
again,
the
another thing I did not
physically
know.
In their adult stage, queen bees and worker bees look way different, but in their larval stages, they're practically identical. It's exactly like two different evolutions that wind up with two different appearances despite starting with the same looking Eevees. The queen and worker bees didn't start off as genetically different, but differences in their environment, royal jelly, or lack thereof.
That makes
led to
Pokemon
wildly
make
different
a
gene
bit more
expression.
sense.
And
Like, just a
these are the
bit, just
only places in
kinda,
nature where this
you know?
happens. Another Eevee-like example happens in the agouti mouse, which has a gene which changes the fur of its coat. These two mice are genetically very similar at birth, but due to differences in nutrition, they have very different gene expressions, with one having a gene expression that causes it to become obese and have lighter fur. Same DNA sequence, different phenotypes, all due to environmental factors. In humans, it isn't just hair color either. Case in point, diabetes, specifically type 2 diabetes. We're often told two things about diabetes that seem in direct conflict with each other. First, that diabetes is a genetic disease. If your parents and grandparents had it, well, it's more likely to be passed down to you.
Yeah.
But also, second, that poor diet and lack of exercise can be a cause of diabetes. So then, which is it? Is it a genetic thing that you're born with, or is it a condition that you develop from eating one too many solo Vermonster challenges at Ben & Jerry's? That is a dangerous prospect, by the way. Do not try to do a solo Vermonster. Oh, Vermonster, you are so good. The answer is it's both. You might inherit a genetic potential for diabetes that's part of the DNA sequence that you're born with, but that diabetes may only get unlocked if you have the bad diet. And if you maintain a good diet, well, you might never have to suffer the diabetes that was encoded into your genes, as those genes remain turned off. On the other hand, someone without a genetic predisposition for diabetes might never get it, no matter how many Big Macs they eat on the reg. And this kind of epigenetics perfectly lines up with what we know about Eevee. In order to become a Vaporeon, for example, a Pokemon not
See, that's the
only
reason I like
exposed to a
Matpat,
specific environmental
'cause,
factor,
like,
in this case, the water
I'll just
stone,
learn a
also
slew
needs
of
to have the
things
right DNA sequence.
that I
Pikachu ain't
never
gonna
knew
turn into a
before.
Vaporeon no matter how many water stones you chuck at
Even
it.
if it's,
That's
like,
because
completely
Pikachu
unrelated to the
wasn't born
video.
with the genetic potential to become a Vaporeon. Well, Eevee was. You need both the genetic component, being born as an Eevee, and the environmental component, the water stone, to produce the epigenetic result, Vaporeon. And where this whole thing starts coming together is when you stop and think about what doesn't change here. The DNA sequence that you were assigned to at birth. It remains the same. It's the thing that doesn't change when these genes are being expressed. Epigenetic changes will cause you to gain or lose certain characteristics, but you'll still always remain the same species. A queen bee and a worker bee are always just going to be bees. No matter what the fur coat looks like, that agouti mouse is always going to be an agouti mouse. As strange as it might seem, that stay the same species thing is actually the case for Eevee. Sure, exposure to a thunderstone will cause an Eevee to turn yellow and grow spiky quills and also somehow gain the ability to attack its foes with electricity, but if you leave it in a daycare with another Pokemon that loves it very, very much, it won't lay a Jolteon egg, it lays an
Eevee egg.
While Eevee and Jolteon might have different entries in the Pokedex, in biological terms, they appear to be the exact same species. The DNA sequence between the Eevee and the Jolteon has stayed the same. The only thing that's changed is what parts of the DNA sequence have gotten turned on. No matter how Eevee quote-unquote evolves, when it comes time to reproduce, it's always going to lay an Eevee egg. Sylveons don't lay Sylveon eggs, Flareons don't lay Flareon eggs, they don't pass their phenotypic traits onto their offspring. But what they do pass on is the genetic potential to express those phenotypic traits. Sure, there are a few exceptions to this, like how Rosalia can give birth to either another Rosalia or the tiny Badoo based on whether it's holding a rose incense. But this also ties in with another part of epigenetic theory, which is natal conditions, the conditions of the mother during pregnancy, and how it can affect their offspring.
I'm about to learn something new
Pregnant
again.
Women aren't allowed to do stuff like smoke or drink alcohol. Well, it's because those substances change the environment for the developing baby, just like a change in the environment for Eevee or a queen bee. This one is just happening before the baby is actually born. In the case of alcohol, a change in the baby's environment can cause birth defects. Birth defects are simply just another name for a change in the gene expressions of the baby. Really bad changes in the gene expression of a baby, but still, that is what it refers to. Basically, from the second you have genes, you can have epigenetic differences based on your environment. And here's where it starts to get crazy when you apply it to Pokemon, because epigenetics goes way beyond just the evolutionary family. This issue of the egg actually unlocks the evolution of practically each and every Pokemon across all of these games. What we've been calling Pokemon evolution for literally decades is simply just epigenetics. Take a look at any other Pokemon, Charizard, for instance. If Charizard
boy,
was a
the
true
best,
evolution of
the OG.
Charmander, when you bred two Charizards together, you would be able to get another Charizard, because animals don't regress backwards in evolution. Having two Charizards get together to produce a Charmander egg would be the equivalent of breeding two cats together and getting yourself a saber-toothed tiger egg.
Huh.
Since at some point cats evolved from saber-toothed tigers, which would be the most awesome pet ever, but it's not the way genetics works. What this all tells us is that the basic DNA of that
Okay, I didn't even
Charizard
think of
is
that.
still just a Charmander. Turning into a Charizard was only the gene expression.
I don't think evolution was
inside
ever
that
like,
Charmander changing. Certain genes,
Yeah,
a big scary fire-breathing dragon monster got themselves turned on, and the environmental trigger that did
I mean,
it
there's so
wasn't
much
a
weird
stone
lore to
or anything
Pokemon that's
changed,
like-
but here it was battling. It was being forced.
Is the
to
whole, like,
battle
evolution
in
thing
order to
even,
level
like,
up. And this is
canonically
where
how it
all the
works,
pieces start coming
right?
together. You see, being forced into stressful situations, like a fight to the death, or I suppose a fight to the faint, is exactly the kind of thing that can affect the methylation of your genes and in turn affect how your body develops. Studies conducted on lab rodents demonstrate how exposing rats or mice to stressful and threatening situations can affect the phenotype that their genes express. According to research done at Columbia University in New York, where rats were exposed to aggressive social interactions, i.e. a much lamer version of a Pokemon battle, in situations where the rodents were repeatedly defeated by larger, more dominant mice, some animals responded to the challenge by becoming more threat avoidant, which is a reasonable survival strategy.
Yeah.
But another strategy was to rise to the occasion by becoming stronger and more threatening, almost like they were leveling up and gradually becoming stronger, unlocking more and more of their genetic potential. Epigenetic theory even goes so far to explain why it's so hard to find upper tier, higher evolutionary forms of Pokemon out in the wild. Why is it so hard to find a Blastoise swimming around, or a Venusaur tromping through the grass? Well, there are costs to being big. Bigger beasts need to carry a lot more weight, meaning that they need to have proportionally stronger legs and eat a lot more food. There's a reason why there's so many more termites and ants in the world than elephants and rhinos. But if a wild Squirtle is just gonna live a peaceful existence out at sea, having a small body that requires less food to maintain is actually gonna be a lot more evolutionarily advantageous. However, if that Squirtle suddenly finds itself caught by a trainer and forced into a battle for its survival, or a battle for its trainer's glory and
So if you
status
were
on
to,
a
like,
regular basis, then what becomes
go
most
into these, like,
important is
phenotypes or
how big of a
whatever,
brawler it
and
is.
change them
Making
around.
evolution into a War Turtle and eventually Blastoise, the single best way to ensure
Like
the
that
chance of
CRISPR thing that a
survival.
lot of people
It was
talk
the
about, like,
environment
recently.
being captured and forced into battles
Then
by
could you
trainers
make,
that
like, a
forced the
superhuman?
genes for giant turtle
Like a
mech
Mega
animals to turn
Man?
on
Like a-
inside a Squirtle. When in the wild, those sorts
The
of genes
strongest
would
man on
largely
Earth,
need to go
the best, like, the
unexpressed. You don't
fastest,
need
the-
them to survive. It's epigenetics
all of
in
that.
action. So there you go. You are now equipped to go around obnoxiously correcting your friends when they talk about Pokemon evolving. You could say something like, well, actually, Pokemon simply alter their phenotypic gene expressions through epigenetic signaling in their environment.
No, I'm not doing
And
that.
congratulations,
Just
no
gonna
one
call it
will know what
evolution.
means
Yep.
But you and me and all the other loyal theorists. scientists out there. But in the process, what we'll all understand is that what we've unlocked here today is a real biological principle that not only fits with what we observe in the Pokemon universe, but also fits the real models of how animals are born with unexpressed traits that can unlock when they encounter specific factors in their environment. It might seem pretty fantastical when you use a leaf stone to turn into a Leafeon, but it's no different from an agouti mouse growing yellow fur because of the nutrition it received. And it was all thanks to this little guy. Let's go Eevee, indeed. But hey, that's just a theory. A game theory. Thanks for watching. Quick reminder, Game Theory merch is still available. Order it now and you'll get it in plenty of time for the holidays. It is the soft...
So, sorry if I wasn't very active and like talking during that reaction. It's actually really interesting. There's a lot of stuff I've never heard before. Cause I mean, I went through obviously an entire like year of genetic science in, you know, biology and all that stuff, and I never heard of epigenetics. I guess they just found it not necessary to go over. I don't know. It seemed really interesting. It actually answered a lot of the questions I was wondering. I always did wonder, like, what determines a queen bee, right? Like, do queen bees lay other queen bees? Like, how is there always only one in, like, a nest at a time? So that kind of makes more sense. But it's just odd. I feel like this would be something that would be more like explored, right, in science class. Like, don't get me wrong, I love me some Punnett squares, but this just seems a lot more epic. Like, so, yeah, the thing I was talking about CRISPR earlier is that's been a recurring theme in my science classes, especially my bioethics and tech class, about, you know, CRISPR. Is it right? Is it wrong? Is it, you know, how will it affect society going forward or whatever if it was used? And it's like, so talking about like all these epigenetics and these things locked out. So could you like then create a person who didn't have that like gene where eventually they'll just, or would you be able to make a gene that doesn't lock out of like, hey, you maintain your metabolism, or, you know, you don't get, you know, gray hair? Would that be possible? Would it be like how would that affect aging in general, right? And of course the whole Superman aspect of like, could you make like a person who's naturally just Arnold, you know, just like, get to the chopper, you know, like smashing folks to the ground with a single punch, being like the badass Terminator that, you know, Arnold is. Like, would you be able to make a person who's base form that? Because I know there's children who are like, oh, this is the strongest kid in the world. He can lift more than most men. And it's like, that had to be genetics, you know, because it's not like this kid had 20, 30 years of weightlifting experience under his belt, you know, to achieve this title, to become this strong. It's just proportionally like he developed muscle in a way that was more efficient, or I guess bulkier. I don't know. It's interesting. God, I learned a lot of things I didn't know. Again, it seems like this should be something that's brought up too when it comes to, yeah, alcohol use and you know, drug use in pregnant women. Like, I've always been told, you know, hey, that's bad, you know, smoking, drinking, doing drugs while you have a kid, because it can lead to birth defects. It can lead to a lot of problems. but like I was never told why. And that's the thing. I never really understood. I guess I just kind of assumed, right, that it was like, hey, the alcohol goes into the stomach, you know, or it goes through like the tube and it goes into the baby, and the baby gets like affected by all the backlash, right, of those drugs, alcohol, and all that, and that's the reason it has developmental issues. I never thought it was like something where these genes just don't activate, right? Like, because even then, yeah, it does, you have to ask like, why are there those backlashes when you're introduced to alcohol and all that stuff when as like a developing kid? And I guess the reason there are those is that it locks off those epigenetic sequence whatever things. I'm probably saying a bunch of scientifically. I'm probably like completely not using the right terms, but that's because, you know, I'm not a scientist, so I'm sorry. But it's interesting. So now, yeah, every time my friends are like, I just evolved my Eevee, I can be like, no, actually, it's epigenetics. And then they'll ask me what the fuck that is, and I'll be like, I don't know. I don't watch Matpat's video. That's I'm not gonna be able to explain it to you like he could. You know, like even now I'm still trying to. So basically, I guess I can understand it and explain it in a way that would be like, hey, in certain environments, these things activate or aren't active, or locked out or unlocked, and that's what determines the thing. But they'll probably ask me a bunch of follow-up questions, in which case I do not know. I would not know the answers. I would just be going on with the trivia. But I mean, obviously the point is, calling it epigenetics, it doesn't really change anything. It's still going to be called evolution in Pokemon. I mean, really, I don't think they really thought of that when they were creating, you know, Pokemon. When they were coming up with the idea, they were probably just like, oh yeah, after intense battles they evolve. You know, they were probably weren't thinking in the terms of epigenetics, all this stuff. Yeah, let's make it scientifically accurate. But that's like the beauty, right, of like reading into games and how they work. It's kind of like, hey, this was probably never intended to be, right, the explanation, but technically it does work. Even though it's not evolution, it's something different, it still works, you know? It's interesting that you can draw these conclusions and they kind of like fit so snugly together, even though it most likely wasn't the original intention. And if anybody has any other examples of like these epigenetic like animals, give me an article or say something, leave a comment, tell me about it. I mean, if you want to take the time, you probably don't, but you know, it's just interesting to me. I might have to really look into this. I mean, obviously, I'm probably gonna forget completely, but you know what? That's okay, because who doesn't forget things from time to time? I don't remember anything from my biology class except for that crickets chirp at different temperatures. Did you know that? They chirp faster or slower depending on the temperature. Maybe. That was a theory that we were going off of in the thing. And I don't know if it's scientifically proven, but it was something we were writing about, like trying to prove. Anyways, I'm going off topic. Point is, yeah, I'm gonna forget to actually research this and look into it and read up into it. But if you have any interesting facts or something that maybe I didn't know or Matpat didn't mention in the video about epigenetics or anything like that, then share with me. I'd love to hear more about it, honestly. Or even your own theories about like what Pokemon evolution actually is. Do you think, epigenetics was always planned? Obviously it wasn't. It was always the plan. Or was it always just this dumbed down level of evolution that they've gone for? That's definitely the case. But, give me your theory, if you want to. I doubt anybody will. But, hey, what can you do? But yeah, thank you guys for watching. I'm Afro. I'll see you guys later.